So we did our art gallery project on elasticity of demand, and elasticity is the degree to which one change causes another change. Since price elasticity of demand is the simplest to understand, we'll start with that. We know when prices increase, quantity demanded decreases. Elasticity tells us how much quantity demanded decreases by. When a large change in price causes a small change in quantity demanded, the demand curve is relatively inelastic. That is, consumers are relatively insensitive to the price change. Relatively inelastic demand curves tend to be more vertical than horizontal. If consumers demand the same quantity of a good regardless of the price, the demand curve is perfectly inelastic. Consumers are perfectly insensitive to the price change. Perfectly inelastic demand curves are vertical. Goods that have inelastic demand curves tend to be products that are necessities, there are few substitutes, and are relatively inexpensive. When products have inelastic price elasticity of demand in the short run, there's a tendency for these products to see large price increases over time. When that happens, a demand curve will become more elastic in the long run. That is because substitutes will be introduced in the long run, allowing customers to become more price sensitive. For example, gasoline has inelastic demand in the short run, but in the long run, demand for gasoline has become more elastic because high gas prices have led to substitutes. Today, we have hybrid cars, electric cars, ethanol, and biofuels. All of these substitutes have increases the long run price elasticity of the demand for gasoline. When a small change in price causes a large change in quantity demanded, the demand curve is relatively elastic. That is, customers are especially sensitive to the price change. Relatively elastic demand curves tend to be more horizontal than vertical. If consumers will demand any quantity at one maximum price, the demand curve is perfectly elastic. Consumers are perfectly sensitive to the price change. Perfectly elastic demand curves are horizontal. Goods that have elastic demand curves tend to be products that are not a necessity, products where there are many substitutes and are relatively expensive. There's another type of elasticity, and it is called unit elastic. A unit elastic demand curve will have price increases cause proportional decreases in quantity demanded. Note, looking at the shape of a demand curve is not a sure way to determine elasticity. A linear demand curve's elasticity decreases as quantity increases. Next is the elasticity coefficient. Another way to determine elasticity is to calculate the coefficient. A coefficient tells us the proportions at which a change in price changes quantity. A coefficient of -2, for example, tells us that a price increase of a given percentage will cause twice as much decrease in quantity. A coefficient of -0.5, on the other hand, will cause a decrease in quantity demanded half the percentage of the price increase. The basic formula for calculating a coefficient is the percent change in quantity divided by the percent change in price. After calculating the coefficient, the absolute value can be used to determine the elasticity. Elasticity values are as follows. If the coefficient is 0, it's perfectly inelastic. If it's less than 1, but not 0, it's relatively inelastic. If it's equal to 1, it's unit elastic. If it's greater than 1, but not infinity or undefined, it's relatively elastic. If it's infinity or undefined, it's perfectly elastic. Something to note is that these are the elasticity values for all types of elasticity. Following the elasticity coefficient of demand is the elasticity of supply, and the price elasticity of supply is a measure of how sensitive the quantity supplied of a good is to changes in price. It is calculated as a percentage change in quantity supplied divided by the percentage change in price. If elasticity is greater than 1, supply is considered elastic, and if it's less than 1, it's considered inelastic, and then if it's equal to 1, it's unit elastic. If it's equal to 0, it's perfectly inelastic, and infinity, it would be perfectly elastic. Something that didn't get its own section on the worksheet but is important to know for elasticity is the total revenue test. When it comes to the price elasticity of demand, the simplest way to determine elasticity is the total revenue test. The formula for total revenue is price times quantity. On a demand curve, quantities fall as prices rise and quantities rise as prices fall. If price rises and total revenue increases, the demand curve is inelastic. And vice versa. If price falls and total revenue decreases, they're going in the same direction. That means that the demand curve is inelastic. And if the price rises and total revenue falls, going in opposite directions, that means the demand curve is elastic. Same thing for price falling and total revenue rising, it's elastic. If price changes do not change total revenue, the demand curve is unit elastic. A straight line demand curve will have an elastic portion at the top, an inelastic portion on the bottom, and a unit elastic point in the middle. If there is a marginal revenue curve on the graph, it can help you determine elasticity. Decreasing price increases total revenue as quantity increases. As the long-run marginal revenue is greater than zero, the unit elastic portion of the demand curve is where MR equals zero. Then decreasing price decreases total revenue since the marginal revenue is negative. In this range, the demand curve is inelastic. Something to note is that the total revenue test only applies to price elasticity of demand.
Decreases. Cross-price elasticity tells us how much a change in the price of one impacts the demand for the other. And when there's a change in the price of a substitute or complement, the demand for the good in question will change. Let's look at some formulas. So the formula for cross-price elasticity is the percent change in quantity over percent change in price, and the price is referring to the other good. Substitute goods have a positive coefficient because an increase in price of a substitute will have an increase in the demand for the good. Complementary goods will have a negative coefficient because an increase in price of a complement will cause a decrease in demand for the good in question. So income elasticity is about how much a change in consumer income causes a change in the quantity demanded. Normal goods are goods that consumers buy more of when their income rises and less of when their income falls. And inferior goods are, like, for example, one-ply toilet paper or, instant ramen, something generic, something you can get anywhere. When consumers' income rises, consumers buy less of these goods, and when income falls, they buy more. One of the non-price determinants of demand is a change in income. So income elasticity tells us how much a change in income will shift the demand for a good or service. The formula for income elasticity is percent change in quantity over percent change in income. Normal goods have a positive income elasticity coefficient, since when an increase in income causes an increase in the demand. Inferior goods have a negative income elasticity coefficient, because if you have an increase in income, the demand for inferior goods decreases. Just a few quick FRQ tips. I would say knowing how to read all of the graphs is very important. Adding to the graphs, being able to look at the tables and understand what you're looking at, what type of elasticity is going on, that's very important. And I would also say having the formulas memorized for the different types of elasticity would be valuable.